most abundant element in the universe. 90% of the atoms in the universe are hydrogen. It's the main ingredient of stars like the sun. It's invisible but powerful. Although you can't see or smell it, hydrogen has more energy per kilogram than gasoline. It's up to 3 times more efficient. It can cost up to $5 to $10 per kilo. Green hydrogen, produced with renewable energy, is still expensive. But countries are investing to lower its price and make it competitive. Saudi Arabia and Australia are investing billions. Countries rich in sun and wind want to become green hydrogen exporters, as if it were the new oil. The largest consumer of hydrogen is the chemical industry. It's used massively to manufacture ammonia and fertilizers, without most people knowing it. China is the world's largest producer. It produces more than 20 million tons per year, although most is gray hydrogen, from natural gas, not clean. Hydrogen can power entire homes. In countries like Japan, domestic hydrogen cells already exist that supply homes with electricity and heating. It can be produced with water and electricity through a process called electrolysis, which separates hydrogen from oxygen using electric current. There's also hydrogen in the human body. It's part of the water we drink and many organic molecules. You yourself are full of hydrogen. It could replace natural gas in the future. Some cities are already testing mixing hydrogen with natural gas in pipelines to reduce carbon dioxide emissions. If you're interested in how hydrogen can change the world and be part of the energy future, stay with us. Don't forget to subscribe, like, and share this video to keep discovering more about this revolutionary energy. Let's get to it. Step 1. Water procurement. The first step in hydrogen production is obtaining water, which acts as the essential raw material in the electrolysis process. Water, composed of 2 hydrogen atoms and 1 oxygen atom, H2O, is decomposed into its basic elements during electrolysis. This water can be obtained from various sources such as rivers, lakes, or even the sea, although drinking or purified water is preferred to avoid the presence of impurities that could affect the process efficiency. The water undergoes a filtration and pre-treatment process, especially if it comes from natural sources, to ensure its purity. This is crucial because impurities can clog the electrodes or interfere with electrical conductivity, which slows down hydrogen production. Additionally, water must undergo a demineralization process if seawater is used, due to salinity that could cause corrosion and equipment damage. Once the water is ready, it's pumped into the electrolysis system, where electricity will separate it into hydrogen and oxygen. Water quality is fundamental to obtain clean hydrogen and maximize the energy efficiency of the process. Step 2. Electricity supply. The second step in hydrogen production through electrolysis is the electricity supply. This step is crucial because electrolysis is a process that requires an electric current to decompose water, H2O, into its 2 basic components: hydrogen, H2, and oxygen, O2. Electricity must be provided through electrodes, generally made of conductive materials, submerged in water. The source of electricity used in this process can vary, but ideally it should come from renewable energy sources such as solar, wind, or hydroelectric. This ensures that hydrogen production is completely clean and sustainable, contributing to the energy transition toward a more ecological future. Using electricity from non-renewable sources would diminish the environmental benefits of hydrogen, as it would involve carbon emission generation during the process. The amount of electricity supplied determines the efficiency of electrolysis. If the current is too low, the process will be slower, while too high a current can generate excessive heat and decrease the process effectiveness. Precise control of electricity is essential to optimize hydrogen production and maximize the system's energy performance. Step 3. Electrolysis process. The electrolysis process is the core of hydrogen production from water. In this step, the supplied electricity is used to separate water, H2O, into its basic components: hydrogen, H2, and oxygen, O2. To do this, water is subjected to an electric field applied through electrodes, which are submerged in water. When electricity passes through water, hydrogen atoms separate from oxygen. At the cathode, the negative electrode, hydrogen atoms are reduced and form hydrogen molecules, H2, which are collected as gas. At the anode, the positive electrode, oxygen atoms are oxidized, releasing oxygen, O2, as gas. The hydrogen produced in this reaction is of high purity, making it suitable for various applications such as fuel cells and other clean technologies. Additionally, this process can be carried out at different scales, from small research facilities to large industrial plants. The electrolysis process is highly efficient when renewable electricity is used, making hydrogen production a clean and sustainable energy source. Step 4. Hydrogen and oxygen separation. In Step 4, after the electrolysis process decomposes water into hydrogen and oxygen, the separation of both gases is performed. During electrolysis, gases are generated at the electrodes: hydrogen at the cathode, negative electrode, and oxygen at the anode, positive electrode. These two gases, although found in the same liquid environment, must be effectively separated so they can be collected and stored independently. Electrodes are designed so that gases don't mix. Collection chambers are used at each electrode to capture the generated gases. Hydrogen, which is less dense than oxygen, is collected in a closed system that channels it to a reservoir, while oxygen is collected separately in another chamber. This separation is crucial because hydrogen has multiple applications as an energy source, while oxygen, although also valuable, is used in different industries like medicine and metallurgy, but is not the main product of this process. Therefore, an adequate separation system ensures the purity of both gases and the efficiency of the hydrogen production process. Step 5. Hydrogen purification. Once hydrogen has been separated from oxygen, the next step is its purification. Hydrogen produced in the electrolysis process may contain impurities such as traces of water, residual oxygen, and other compounds that can be generated during the process. These impurities must be eliminated to ensure that hydrogen is of the highest possible quality, especially when it will be used in sensitive applications such as fuel cells and industrial processes. To purify hydrogen, different methods are used depending on the desired quality and final application. One of the most common methods is filtration and drying, in which gas is passed through filters that remove solid particles, and a dehumidification system is used to remove excess water. Additionally, pressure swing adsorption technologies, PSA, can be employed, which allow elimination of other unwanted gases such as residual oxygen or carbon dioxide. This step is crucial because even small impurities can affect the efficiency and longevity of systems that use hydrogen, such as fuel cells or chemical reactions where hydrogen is a reactant. Effective purification allows obtaining hydrogen with a purity of up to 99.999%, making it suitable for use in various technological and energy applications. Step 6. Storage and transport. Once hydrogen has been purified, the next step is its storage and transport. Because hydrogen is a very light, low-density gas, its storage and transport present some technical challenges. Specialized systems must be used to ensure hydrogen remains safe and ready for use. One of the most common ways to store hydrogen is through high-pressure storage, where gas is compressed to extremely high pressures, reaching up to 700 bars. This type of storage is used in fuel cell vehicles and various industrial applications, allowing efficient transport and use of hydrogen. Another option is liquid-state storage. By cooling hydrogen to extremely low temperatures, near -253 degrees Celsius, the gas volume is considerably reduced, facilitating its storage and transport in large quantities. Although this process requires a significant amount of energy and specialized refrigeration systems, it's useful for large volumes. Storage in solid materials is also being researched, where metal hydrides absorb hydrogen. This method is still in development but offers an interesting alternative for the future. Hydrogen is transported by tanker trucks, pipelines, or ships, depending on the quantity that needs to be transported, always with strict safety control due to the high reactivity of the gas. Step 7. Final use. Hydrogen has a wide range of applications that make it a key source for various industrial and energy sectors. Its versatility allows it to be used in many ways that are revolutionizing how we produce and consume energy. One of the best-known applications is in clean energy generation. Hydrogen fuel cells, used in electric vehicles and stationary energy systems, produce electricity without polluting emissions, only water as a byproduct. This makes it an attractive alternative to fossil fuels. Hydrogen is also used in the chemical industry, especially in ammonia production for fertilizers, an essential component for modern agriculture. Additionally, it's used in petroleum refining processes and in manufacturing products like methanol and other chemical compounds. In the transportation industry, Hydrogen has the potential to replace traditional fuels in heavy vehicles such as trucks and trains, which would significantly contribute to reducing the sector's carbon footprint. Furthermore, hydrogen is used in steel production and other heavy industries, where its role is to replace more polluting energy sources. In summary, hydrogen is not only a clean energy source but also drives the transition toward a more sustainable economy. Hydrogen is undoubtedly one of the key pieces for the future of clean and sustainable energy. From its capacity to generate electricity without emissions to its fundamental role in chemical and transportation industries, this resource is revolutionizing the way we think about energy. If we continue developing technologies to optimize its production, storage, and use, hydrogen can be the engine of a global transition toward a greener and more efficient future. If you're passionate about learning more about this powerful resource, don't forget to subscribe, like, and share this video. And tell me in the comments, what other element, metal, or mineral would you like us to investigate in an upcoming video? Or is there any process that makes you curious? I'm reading everything. See you in the next one.